A nuclear power plant creates electricity by using the heat from a controlled nuclear fission chain reaction in the reactor core to boil water into high-pressure steam, which then spins turbines connected to electrical generators. In a pressurized water reactor, PWR, water remains liquid under high pressure, around 150 to 160 bars, heating to about 300 to 325 degrees Celsius, before transferring heat in a heat exchanger to create steam for the turbine. A boiling water reactor, BWR, generates steam directly within the reactor vessel at similar pressures and temperatures to turn the turbine. The high-pressure steam then cools in a condenser to form water, which is reused in the cycle. Operation of a nuclear power plant. 1. Heat generation. A nuclear reactor's core contains uranium fuel where a controlled fission chain reaction occurs. Neutrons strike larger atoms like uranium, causing them to split into smaller atoms and release a tremendous amount of energy in the form of heat. 2. Heat. Transfer to steam, PWR, Pressurized Water Reactor. High-pressure water circulates through the reactor core, getting heated to over 300 degrees Celsius, but remaining liquid due to the pressure. This hot, high-pressure water then passes through a heat exchanger, steam generator, to heat a separate water supply. BWR, Boiling Water Reactor. Water directly contacts the reactor core, and the heat from fission causes it to boil and turn into steam within the reactor vessel. 3. Steam to turbine. The high-pressure steam from either the heat exchanger, PWR, or the reactor vessel, BWR, is directed to a turbine. The force of the steam causes the turbine's blades to spin rapidly. 4. Electricity generation. The spinning turbine is connected to a generator, which converts the mechanical energy of the turbine into electrical energy. 5. Condensing and reusing steam. After passing through the turbine, the steam is condensed back into water in a condenser, which is often cooled by water from a lake, river, or cooling tower. This water is then pumped back to the reactor or steam generator to repeat the cycle. Operating data example: Pressurized Water Reactor, PWR. Primary loop, reactor water. Pressure, approximately 160 bars, 16 megapascals. Temperature, inlet, 289 to 325 degrees Celsius. Outlet, ~325 degrees C. Secondary loop, steam generation. Pressure, approximately 60 bars. Temperature, 275 degrees Celsius. Criticisms of nuclear power: nuclear waste. A significant challenge is the long-term storage of radioactive waste from spent fuel. High initial capital costs. Building a nuclear power plant is extremely expensive, and the construction time can be lengthy, often around 7 years. Limited fuel source. Uranium is a non-renewable resource, as it exists in limited quantities, making nuclear power not a renewable energy source like wind or solar. Safety concerns. Although rare, the potential for accidents and the risks of radiation release require robust safety measures, such as containment structures,